extend my thanks and appreciation to this the charge of the conference. I'm Naser Hussein, PhD student at the University of Tunis Ilmanar. I present this research to you with my teams, Jihene, khoualdi, and Ilhem Abdelmoula, and Kaffel. Excuse me. My work is blockchain-based approach for privacy and security in IoT applications, systematic review. Internet of Things has a global domain with adequate connectivity in the moment, data collection, and autonomous decision making. But rising number of heterogeneous, extremely unconstrained IoT devices pose serious concern regarding data privacy, security, and the trust management. So, blockchain technologies come into the limelight for strengthening security and privacy in IoT system in a decentralization manner, giving a system immutability and transparency and distribute trust. This study proposed a systematic review of blockchain-based approach that aim to enhance the IoT application privacy and security and focus chiefly on the healthcare and supply chain and smart city. In fact, this review used the structure methodology find, select, or evaluate and synthesis relevant peer review study published between 2018 and 2025, taken from major scientific database IEEE Explorer and ACM libraries and science direct Springer's and Scopus studies. Article were also examined to narrow the scope of study and set the subject. The selected study are analyzed and classified based on the security goals, for example, confidentiality and integrity and authentication. Privacy, preserving the technologies, anonymization and different privacy or zero knowledge proof blockchain configuration, public or private or consortium, and the consensus mechanism. The finding reveal ground the body of research applying blockchain to wide range of IoT domain, healthcare or smart city and supply chain. However, the integration of blockchain in the IoT also face challenge such as scalabilities and latency and resource overhead, especially in the real-time concentration environment. Study aims. This study is specifically this identity and categories blockchain based on approaches for enhancement IoT privacy and security. The second aims analyze the architecture and the functional aspect, including the consensus mechanism and the privacy preserving technologies. The third aims examine the practical challenge, research gap, and the future direction for scalables and secure IoT blockchain integrations. Research methodology, the SLR framework, the semantic review framework has purpose the definition or defining the structure and principle of the review, transparency, security, and efficiency and innovations. Planning the review. This phase involves defining the purpose of review, creating a research question, and design the review protocol. And the review, in this phase, we complete the review with structure search, selection of study, quality research, and the extension of data. and reporting the review. The last phase include the scientific the evidence, analyzing the research and reporting them as a structured way in the interpreter. The structure process expand to minimize patient and improve evidence quality in field with the tendency and various disciplines and rapidly changing evidence such blockchain and IoT. This is the some research question. The first research question: what blockchain-based approach has been proposed to address the privacy and security challenge in IoT application? So, and another question: how do these approach differ in terms of architecture or consensus mechanism, privacy or security goals? The third question, what the current research gap limitation and potential future directions? This is background and the theoretical foundation, the IoT, the definition of IoT and characteristics and application. The in simple word definition, IoT refer to network of interconnected heterogeneous and physical device capable of sensing, processing, and communication data automatically without human intervention. IoT supporting technologies. Several technologies support the concept of IoT identification technologies, network and communication technologies, and software and hardware technologies, for example, Wi-Fi, Bluetooth, and Zigbee, and others. IoT application domain. The Internet of Things has become integral to numerical sector, enable automation, real-time monitoring, and intelligent decision making across both personal and industrial context. IoT application domain in this work impact actually is we treat with the some or important application because the Internet of Things become integral to numerical section, enable the automation, real-time monitoring, and intelligent decision. Some application industry, smart cities, and resource management or energy or smart home. But we focus on the healthcare and supply chain and smart cities. Actually, IoT layers architecture, Internet of Things, built on a network of interconnected embedded sensors and devices that typically features modern process capabilities, limit memory, low powers, and adequate identifier, while numerical steady purpose IoT architecture with a varying layer structure. In fact, layer الperception layer أو sensing layer, sensing and actually the detect and measure environment condition or event, temperatures and humidity and motion, and another actually to execute action in the response to control command or stimuli. This sense convert the physical parameter into digital signal, while the actual perform actions based on the control signal, enable the interaction while physical world. Another layer, network layer, act the channel for data exchange from sensor, the actuator, and the gateway to data process and application layer. For example, Wi-Fi, Bluetooth, Zigbee, 4G or 5G, or LoRaWAN. The middle, so the middle layer where position between the network and application layer. This layer handle data management, storage, process, and service abstraction. For example, technologies and component, middlewares, a platform, edge computing, fog computing, or clouding. processing layers decide analysis, process, and storing large volume of IoT data, often using the big data analytic AI or machine learning algorithm. The last layers, application layer, this layer deliver specified service to user depend on the case, smart home, healthcare, agriculture, and industrial monitorings. The security and the privacy challenge in IoT. In fact, this represents the more challenge in IoT system, healthcare or supply chain or smart city. The IoT network are prime target for cyber attack, including unauthorized access, data tampering, and distributed denial of service DDoS or DDoS attacks, and research concentrating on many IoT devices such as limit CPU power, memory, and energy make the implementation of a traditional security mechanism is very, very difficult. And protocol diversity introduce the further complexity. The IoT landscape include various wireless communication like Wi-Fi, Bluetooth, and Zigbee. Blockchain architectures and technical foundation. Blockchain system can be broadly categorized based on the access permissions and governance model, which define how who can participant is network access data and read or write to distribute the data. There are three types of blockchain architecture: private, public, hybrid. In simple words, the private only invited member can participate, view the information, and make change. But the public, anyone can simply access it and start execution, viewing, or validate a transaction on it. Hybrid combination of private and public blockchain is used to structures both type blockchains. Some technical characteristics of blockchain transparency: all peer node on the network maintain a full replica of the ledger and can be verify all transaction with the network. And another temper proof traceability, transaction once authenticate and record cannot be altered or deleted. The privacy and security consensus and cryptographic properties of blockchain allow node to act trustless, verifying transaction individual without knowing other parties' identity. That provide use privacy. High reliabilities, all nodes contribute to network stability by maintaining the ledger and validation transactions. Consensus algorithm, there are five or more, but this is very important or more important. Proof of work. Proof of work require participant, now a miner, to use the computational power to validate the transactions. And proof of stake. Proof of stake choose the validate node that verify transaction based on how much cryptocurrency they has staked. And another type of proof of authority. Proof of authority priorities identity and reputation. It is typically used to permission blockchain. Proof of elapsed time. Finally, the randomly select who get to add the next block of a transaction. And the last, delegate power of a stick user for to select a set of individual delegate or witness. Impact the literature review finding over select study 195 studies, 55 studies were excluded, and the mining studies 140, and another 45 studies were excluded 95, and the result 58 studies distributed application domain, blockchain architecture, consensus algorithm, and the privacy and security applications. This overview of select study from 2018 to 24-25, 60 study for smart city and 20 study for supply chain and 24 study for healthcare. The IoT application domain, healthcare and supply chain and smart city. In the healthcare domain, the more subject or the most important domain, IoT healthcare, IoMT, medical record and electronic health record and remote patient monitoring and electronic healthcare systems. But supply chain, food supply chain, agri-food supply chain management, and pharmaceutical drug supply chains or food industry. But in the smart city, we treatment with the IoT device and parking surface and data management industry and firmware management. In fact, the comparative analysis of blockchain-based IoT security and privacy. This table represents the healthcare. For example, the number of papers and the years of study problem statement in this study security and privacy issues lack integrity and low scalability, single point of failure, and what the advantage of blockchain in this study, decentralization and distributed immutabilities and security, and what the time usage in this study or another study, for example, private permission or Ethereum, and what the consensus algorithm used, proof of authority or proof of work or another, and how can we use the smart contract on or off chain smart contract and using the interplanetary file system. In fact, the security and the privacy consideration, for example, in this study, confidentiality and integrity, access control, and privacy. In the supply chain, for example, some studies, comprehensive analysis of blockchain based on the supply chains, at the same slide, some problem, single point of failure, counterfeiting, attacks or scalabilities, and the advantage of blockchain, type of platform, and a consensus algorithm. Security consideration to the IoT applications. In this slide, we compare the healthcare and supply chain and smart city with the another and the some security consideration, privacy, confidentiality, integrity and access control, authentication and authorization, and availabilities. So, security considerations ensure the reported security and privacy essential for the successful deployment of blockchain-based IoT system. This section presents a classification of select study based on the security objective, threat model, and the standard address to this blockchain integration. And in fact, several study specify focus on the counter will now IoT threat, sample attack, denial of service, man in the middle, and another. These threats are mitigated through a range of security mechanisms, including access control, authentication, and data integrity or non-reputation and system resilience. This table represents the many of study in healthcare. Actually, in healthcare, the more study focus on the confidently as show us home and privacies. But in the supply chain, the study focused on the traceability and transparencies, as shown in figures. In smart city, the study focus on the confidently more and authentications. So, blockchain technologies significant threat security and privacy in the IoT system, but tackling fundamental vulnerabilities. The the decentralized architecture eliminates single point of failures, while immutable ledgers ensure the data cannot be tampered with after recording. Advanced cryptography method, including encryption and zero knowledge proof and anonymization. Further, excuse me. Further safeguard sensitive information. Smart contract play a critical role by automate access control, allowing data sharing exclusively with authorized entity. In healthcare or smart city or supply chain. In healthcare, blockchain facilities should secure management of patient data collected from IoT devices, such as wearable and remote motion. Encryption, the healthcare record, encrypted healthcare record, remaining accessible only through patient health private key, with smart contract enforcing dynamic conscious policy elegant with regulation. This framework also provides a transparent audit trail and ensuring data integrity by hashing real-time medical reading, thereby supporting the reliable diagnosis. For smart city application, blockchain enhanced citizen privacy by anonymizing sensors data and enable residents to interact with urban service via pseudonymous identities. Permission blockchain allow secure and confident cross identity data exchange without exposing raw data set. But in supply chain, blockchain offer traceability and transparency by recording product information and transaction immutability, prevent the fraud and unauthorized data manipulation. Despite these benefits, challenge remain scalability issue arise from the high computational demand of the conscious algorithm, which can strain resource limit IoT device probabilities between blockchain platform and legacy IO system also require further development to ensure the seamless interaction to address these concerns. Research focus on the light of this consensus algorithm. So, the conclusion of this study, this article over a comprehensive comparing session of numeric IoT focusing study blockchain in application, healthcare, and smart city and supply chain. And this comprehensive brief can clear in this table 1, table 2, and table 3. Blockchain interaction with IoT not only strengthens security and privacy, but also facilitates automation, transparency, and interoperability and long-term system resilience. However, several critical challenges remain, including the scalability limitation, energy efficiency concern, and the need for lightweight consist mechanism suite for resource constrained IoT device. This survey provides in-depth analysis of security and privacy preserving strategy in blockchain IoT environment and highlighting ongoing design challenge and emerging solution. Looking forward, blockchain role in IoT hand is promised from securing smart cities and autonomous system to optimize the supply chains and personalize healthcare despite persist obstacle and continuous innovation initiate to establish blockchain-enabled IoT and foundation. So thank you very much. Thank you very much.